of arc cosine of 3/4. So I intentionally am using the same two like parent functions. There's a tangent and there's cosine in these, but I've switched the order, right? I put the tangent on the outside, I put cosine inverse on the inside, and then I put 3/4 instead of 3 pi over 4. So what is this in here? What is that going to be returning to me? A number or an angle? No. Does the arc cosine spit out a number or an angle? It spits out an angle, right? This is saying where on the unit circle is the x coordinate 3/4. And you're restricted between 0 and pi. Do we know that? Is that a common? No. It's not a common one, is it? So I actually cannot answer this question. I don't know what angle produces that value, right? So do y'all remember what I did? Reference triangle. Good. So what we did is we call this theta, right? That's some angle that we need to find. And if I look at this problem and I rewrite it, then all I really want to know is what's tangent theta. So then I come over here and I write down an equation. What's that equation going to be? Theta equals cosine inverse of 3/4, like that. Now what?
Can you switch the arc cosine to the cosine?
Yes, we're going to do cosine on both sides. And then this is where that reference triangle came into play. So I draw a triangle, right triangle. I label my angle here theta. And the fact that cosine is 3/4 means that my adjacent side to my angle should be 3 and my hypotenuse should be 4. So this should be 3 and this should be 4. Now that we know that this is 3 and this is 4, I can get this side. Now, why do I even want this side?
Square root of 7, so you can answer your question.
Yeah, because the original question here is tangent. What's tangent theta? Tangent would require, if you look at this triangle, tangent is this side over this side. So I need that side, right? Which is square root of 16 minus 9, so root 7. So my answer is, this is equal to root 7 over 3. I want to do another one of these. All right, I want to do one more of these. I like these problems. Like that one, I really always have liked those problems. Okay, tangent. Well, let's do cotangent just for fun. Of sine inverse of -4/5. Thank you. Set it right there, Blake. Thank you. So you look at this inside part. Is that returning to you a number or an angle? An angle. I think I'm behind a day on this. Today is the 12th, right? Here you go.
Yes, sir.
Okay. This is going to return an angle, right? And do I know that angle? Is this a common value on our unit circle? It is not, right? You're asking yourself, where's the y coordinate, right? Y coordinate because it's arc sine. Where is it -4/5? And that's not happening, right? So I, again, call this theta. That means ultimately I want to know what cotangent theta is. And then I create an equation here. Theta is arc sine of -4/5. Now, the reason why I wanted to give you one more example is because this is a negative in here, and I think you have to be a little careful. It wasn't obvious here, the danger. This one will illustrate the danger a little bit. we want to know where our y coordinate, right? What angle on the unit circle will give me a y coordinate of -4/5? What quadrant am I going to have to be in? In the fourth quadrant. So imagine this. We're down, our angle goes like this, right? And we're over here somewhere. Actually, I shouldn't say that. Our angle goes this way because we're not allowed over here, are we?
No, sir.
Now, your y coordinate has to be -4/5, means that when I draw my triangle like this, I should draw my reference triangle in a way that I'm actually taking this y value to be negative. See here, why didn't it matter? Cosine was positive, right? This was a positive thing. Cosine is positive in the first quadrant. So you can imagine this was actually drawn in the first quadrant. That triangle was drawn in the first quadrant. Cosine is the x coordinate. It was positive. So this should be, if I take sine on both sides, sine is which side over which side? Opposite. So what am I going to label this side as? -4. -4, because I'm down 4. -4, and then this side's 5. Now, I want cotangent. Cotangent is adjacent over opposite, so I need this side. So I can use Pythagorean on that. It'd be root 25 minus 16, which is root 9, which is 3. Yep, it's Pythagorean triple. Yep. So now we have our cotangent. Our cotangent should be -3/4. It doesn't matter where we put the negative, so
It's going to be a negative fraction.
there it is. -3/4 is the answer. Is that all right?
Yeah.
Okay.
Professor, how did the quadrant come into play when it had to be negative and it was?
Because your sign was negative.
How did the quadrant come?
Where would you have a negative y?
I mean, even if you didn't take into the quadrant into consideration, just make up a retrospective.
Okay, so what if we would have done a regular old triangle? Okay, so let's try it. If we would have done a regular old triangle based on this, right? Like this, then you want me to call this -4? Hold on, I'm trying to think of an example.
Isn't it because the sign has it, if it's going to be negative, you have to have the sign matching in a negative quadrant?
Hold on, let me think of something real quick. It wouldn't cause a problem here. I'll give you one that it would cause a problem, all right? Just so we can resolve that, all right? What if we did this? Let's do sine of arctangent of 2. And you know what? Yeah, we could do that. Let me see here. Make it -2. Trying to force us into a quadrant, but I just won't do it. Okay, I'll try it with this. All right. This one right here, this produces an angle, right? So we really want to know what sine of this angle is. So here, if we were to write this down, theta equals arctangent of -2, then if you just say tangent of theta equals -2, right, like this, and then I go to draw a right triangle, how do I label this?
Opposite would be -2 and adjacent would be 1.
Okay, so you're going to rewrite this as -2 over 1, right? So this is -2 and this is +1. All right, so why couldn't I have done this, though? Could I have done 2 and -1? Wouldn't that give you the same ratio?
Yeah.
Yes? And so if I asked for sine, right? If I asked you for sine, you're going to give me -2 over this hypotenuse, right? But if I did it this way, I'm going to give you +2 over this hypotenuse, and we're going to have two different answers. So what's important to understand here is the quadrant you're in. And when you look at this tangent as -2, what quadrant must I be in? Now you have to remember arctangent, right? So where were we restricted to? Arctangent, we're only allowed here, right? So when I draw my triangle, the only way to draw my triangle properly is to do like this, and then it would be -2 here, right? And this would be 1. And so the way you did it would have been correct, but I could have done it a different way, right? I could have done +2 over -1, and it would not have worked. Does that make sense or no?
Yeah.
You should, no? No?
Because like, we don't do, like, if you have a -2, you don't take 1 as negative, you take that value as negative.
Well, you don't have to, though. I mean, look, what if, when you rewrite a fraction, right? When I rewrite -2, there's nothing that says that that has to be -2 over 1. It could be 2 over -1, right? It's your choice, my choice, I can choose. And it's dangerous, that's all I'm getting at. It's dangerous. If you just draw arbitrary triangles and label, you set up yourself for a potentially bad issue. So I like to pay attention to what quadrant you're in. Here, because it's an arctangent, we can only be in this quadrant or this quadrant. The only way tangent can be negative is if we're in the fourth quadrant, and that means the y-coordinate has to be negative, and the x-coordinate has to be positive. So that forces the -2 and 1 like this, and then everything will work out. All right. I was really hoping, oh, well. Okay, I'll give you just one more, sorry. Cosine, let's go cosine of cotangent inverse of -3. Yes? So now call this theta, because that's going to produce an angle. Theta is equal to cotangent inverse of -3, which means that cotangent of theta is -3. All right, and now let's draw a triangle and not pay attention to where we are. So how do you want me to label this? Cotangent is,
1 over 10.
so how do you want this? This should be the adjacent over the opposite. Do you want me to go -3 here and 1 here? Or do you want me to do 3 here and -1? You see, I could do either way.
Yeah.
So which one do you want? Do you want the -3 or the +3?
-3, negative.
Well, I don't think we should have to guess. And that's why I was trying to stress to you the importance of understanding the quadrant you're in. We shouldn't have to guess which one of these it is. So before I actually do this, what I wanted you to look at was what was the restriction that we play with cotangent? 0 to pi. So if you're 0 to pi, you're not allowed down here. And the only way that you can get a ratio, remember this is your x-coordinate over the y-coordinate, right? That's what cotangent is. The only way to get a negative ratio is if one of these is negative. And the only way that's going to happen is if I'm in the second quadrant. My x is negative and my y is positive. Yes? So I would prefer to draw a triangle like this, call this 1 and call this -3. -3, 1, and then you get your hypotenuse and you can answer everything. I hope that illustrates what I was trying to get across. It's just dangerous. All right, 25 minutes. And we're doing pretty good, actually. How about tangent of cosecant of u, right, as algebraic function? Do they put function notation? Oh, expression, sorry. Expression. I did one of these in class, and I don't know if you remember, I graphed the two. Like I graphed this, and then I graphed the thing we came up with, and they were identical. So we want to try and do this. So we're going to follow the same procedure we just followed. This no, hold on. This is an arc cosecant. I forgot my arc cosecant in here. This in here returns to us an angle, right? So we call it theta. And then over here we write theta equals arc cosecant of u. And then we take cosecant on both sides. And we get cosecant theta as u. Okay? Now, what is it that we really want? Since we rewrote this and called this theta, what is it that we really want over here? Tangent theta, right? So we would like to know what tangent theta is. I know what cosecant theta is. Cosecant theta is u. So I'm going to draw my reference triangle. Reference triangle here. Now, should I be concerned about restrictions? Absolutely. I mean, this is arc cosecant, so we are between -pi/2 and pi/2. We do have restrictions here. But u is a variable, like we don't even know what it is. So we can't really gather any more information. We don't know if it's positive or negative. We have no idea right now. So cosecant is u tells me that this triangle can be labeled how?
Opposite as 1.
This is 1 and this is u, right? That way cosecant is hypotenuse over opposite, so u over 1 would be u. So that follows that equation. I want to know what tangent of theta is, so I want this over this. This is going to be square root u squared minus 1. Sorry. Now what?
Set it up to tangent.
Yeah, tangent is just this over this. So 1 over root u squared minus 1.
It's okay to leave it that way, right?
Or do we rationalize it?
Yes. No, leave it. Absolutely, leave it like that.
What would it look like if you rationalize that?
You would multiply top and bottom by that root, so you would get u squared minus 1 on top, and on the bottom you get u squared minus 1. Yeah. So it wouldn't look much better. All right, so that covers a majority of what we did without talking about identities. So now some identities. Who sent me that text with the picture after class? Who was that? No? Someone sent me a text after class last time? No? About that, remember that problem I said try and find an easier way? I thought someone sent me.
Oh, someone sent you a text on it?
Someone did. I thought it was, I don't know what that was.
Was there an easier way?
I need to look at it. I need to look at it. Yeah, I didn't really see an easier way. All right, you ready? I'm going to give you an identity here. How about I give you a few, and then y'all can work on them? Yeah, see how you do? All right, so show. Is there anything else that you want me to talk about or do before I cut you loose on these? No? Does it feel like there's a lot of information on this test, or does it feel like it's reasonable? Yeah, it seems like more? Yeah. This one just looks interesting. That's not the one that I thought looked interesting. This one does.
So approximately how many identities will it prove in the exam?
On the exam, I'm going to have you probably prove, I don't know, 10 or 12 of these. No, I'm just kidding. I tried to keep a straight face, sorry. Honestly, what I'm thinking of doing is probably giving you 5 and asking you to do 3. And that way, if you get hung up on one, you can move to something else. Because it is, I know with identities, sometimes you can just get snagged. And I know that sounds like a good thing. Oh, give us 5 and we get to choose 3. But that also slows you down. Like if you take one that. So I would not anticipate more than 3. But I haven't made the test, so I don't know how many questions there are on the test yet. I've got the whole weekend to do that. All right, so you'll go ahead and you'll want to work on those, and while you're working them, do you want me to just put the answers up here? Like just write them on the board? You don't have to look at the answers. Okay, go ahead. I'm going to kill the video for now. Yes.